name is Alan Moya. I am a chemical engineer.
My name is Brendan Padilla. I'm a mechanical and aerospace engineer.
My name is Isai Lopez, and I am a chemical engineer. And this is Team Thermoset Aerogels. We are in Chemical Engineering 361 with Neda Sakaran at New Mexico State University. The history of thermoset aerogels. Aerogels were first made because of a bet between Samuel Kistler and Charles Learn. Kistler was challenged by Learn to evacuate the liquid out of a gel while still having the gel keep its volume. The method he decided to use was supercritical evaporation using CO2. The image on the right is an electron microscope image of the pores of a thermoset aerogel. This is what gives a thermoset aerogel its insulating properties. And the image on the left is a thermoset aerogel in the scientist's hand. The fabrication of aerogels is pretty much what chemical engineers are most concerned with. The aerogel begins as a resin into a separator, and the other unit operations that the chemical engineer should be familiar with is working with gaseous CO2, heat exchangers, liquid CO2, pumps, condensed CO2, heaters, working with alkyl gels, extractors, and then being able to separate and dry an aerogel using ethanol. So pretty much the raw material resin enters hydrolysis, becomes a solution, is condensed into a gel. After gel ripening, it becomes an alkyl gel, and after supercritical drying using CO2, it becomes an aerogel.
Thermoset aerogels serve two purposes in aerospace. First, they are used to capture particles in space because they are less brittle than other materials and they don't damage smaller particles whenever they capture them. They are also used as heat tiles for re-entry into Earth's atmospheres due to their high insulation properties.
So for civil engineers, thermoset aerogel is widely used as an insulator. As you can tell on the top of the house, it is a house with standard insulation, and it is losing a lot of heat, which in return costs a lot of money for the people owning the house slash businesses. In the bottom, it's a house insulated with thermoset aerogel, and it is a lot better at maintaining its temperature inside, which in return saves money. All right, here we have a table with aerogel and standard insulation. As you can tell, it is less dense, which means it weighs less. It has better speed of sound insulation, better size of micropores, thermal tolerance, and melting point, which means it can withstand a lot more heat and not let heat escape. As you can tell in this video, we have a thermoset aerogel being placed on top of a burner, and on top of the thermoset aerogel, there's a Hershey kiss. Now, the purpose of this is to show that the thermoset aerogel has really great properties with heat, which doesn't allow the heat reach to the chocolate and melt it, which is how it keeps the heat inside the buildings without losing money.
The global and economic impacts of aerogels are that the demand has increased. From 1996 to 2016, the number of patents filed related to aerogels has increased by 500%. It is currently worth $260 million and is projected to pass $1 billion by 2027. The pie charts below are of the industries that thermoset aerogels are involved with, and the most notable thing is that the aerospace and automotive industry is expected to grow extremely or a lot by 2027. And here are our references.